I've given some of the antecedents of this topic at prior Hack in the Box shows. I know that some of you who were at Cyber Week in November will recognize a couple of the graphics here, but I promise this is all new, other than the words we wrap around it. So everybody complains about the weather, but in this audience, and especially these speakers, in this conference, people are accustomed to actually doing something about it. And it's always my pleasure to be with you. I wish it could be in person, as I wished last year. So I promise that, if we can get together, I'll be there. So Protective DNS has been in the headlines this year, but it's not a new idea. It's simply some label engineering applied to a concept that has been floating around for at least a decade in my hands and about another decade before that in the hands of others. And so what it really means is DNS that is not true. It's where you ask a question and the answer that you get, instead of just depending on where Akamai thinks you are for content delivery purposes, it might actually depend on what your security policy is. In other words, some answers are hard to digest, or if you try to digest them, you're going to discover that they are very uncomfortable for you. And so that's the general topic area. But I hope to motivate it and motivate you to investigate it further and to put some context around it, because in the announcements that have come about using this new terminology of Protective DNS, some important details that have evolved in the last decade or so have been lost, and I wish to restore those. We will also have a Q&A where I'll be joined by one of my colleagues from the day job, and who just texted me. Hope that's not important. Anyway, so please do come to that. It's immediately following this hour. Very well. This is what I promised to talk about, and what I call your attention to is the United States government. Although it's not the government of everything, it is the world's largest single buyer of IT products and services. And so when they talk, the industry who makes that kind of thing tends to listen. And indeed, that has happened. So what they did is they came out, the Department of Homeland Security and the Department of Defense came out in March of this year and said, yeah, you all ought to start using Protective DNS. And here's kind of a list of places that you could get that from. And, we were jazzed. All of us who've been in this industry for a long time were jazzed. But it turns out they didn't mention us. They didn't mention our approach. They made it seem like in order to use Protective DNS, it was necessary to send your DNS traffic out into the cloud and let one of the cloud providers, who they named in their announcement, be your DNS provider. And, I guess that some people want to do that. I don't do that, but a lot of people are pretty comfortable sending all sorts of things to the cloud. But I don't. And we've been doing something that we now call Protective DNS, because that's the new label, for a long time without the cloud. And I thought perhaps we should tell the world, yeah, it's a great idea. And if you care about not sending your DNS requests into the cloud, let us show you how to do that. But first, let's back up a bit. It used to be that the set of hosts that were reachable on the internet was so small that you could list them all in one file, which they did. And that file changed so infrequently that you could just download a new copy every week. And so everyone did. And it was small enough that that was not a problem. Of course, that was the pre-commercial research and education phase. And eventually it became obvious that this internet thing was going to catch on. And so somebody somewhere said, yeah, we need a distributed naming system. And there was a bake-off, and DNS won the bake-off, and that history has been told, so I won't go into it here, except to say that as we stand, or as I sit today, DNS is used for almost all internet activities. There's one or more DNS transactions that it has to complete before you can do anything, and that includes clicking your mouse in your web browser. So luckily, it's so fast that you don't notice how many requests are being sent, and there's a fairly deep back office. You don't notice how many other servers have to be consulted in order to make your question successful. But this is happening, got to be hundreds of billions, if not trillions of times per day by this time. And it's not just address lookups. Originally, it was, I want a telnet somewhere, so I've got this name. I don't remember the address. Frankly, that's kind of bullshit. We remember the addresses. When there were so few of them that you could list them in one file, you just remembered the addresses. But eventually, we needed a way to do this. And so it was just a way to find the address. But now it's got a lot more. Address is probably the biggest single thing that still comes from DNS, but it is, it's a small part of the total by type. So DNS is like BGP. You have to have it if you're going to reach the things you want to reach. BGP glues us together through the routing system. It says how you would get a packet from here to there once you have an address. And so DNS is like that, except it's before that. It's how do I get the address? Although, of course, you have to have BGP to reach the DNS. So it's a bit of a recursive dependency there. It's also like NetFlow. In other words, if you are able to see DNS, then you know what's happening. And if you can see the kind of DNS requests that a given population is making, like let's say your customers or your family, your employees, then to a first approximation, you kind of know what they're doing. You don't have to see the traffic if you know what names they're looking up. I mean, I guess some people want to see the traffic too, but this is huge in terms of just characterizing the access to resources. DNS is as important as NetFlow. It's also like the spice. If you control DNS, you control the universe. So there's a lot of interest in controlling DNS, a lot of money to be made if you can sort of force DNS to work your way. You may have noticed that there's a lot of .this and .that, new generic top-level domains. These are generally a bunch of companies who think, the .com is very successful. I want to be like them. And so they go pay a lot of money to register a name, and then it turns out that .com is kind of hard to duplicate. So it worked once, but there's a lot more than money at stake. There's a lot of politics, a lot of political control. There was a huge problem for one of the U.S. governments a decade or two back when .XXX was allocated, and everybody assumed that the U.S. government had approved it. Well, no, we didn't, or they. I wasn't there. It's self-governed. The people who are using it and maintaining it have a system, and they added .XXX, and please don't blame that on the U.S. government. But there were a fair number of people around the world who thought that the internet should not have that type of sex quite so visible. XXX, XXX means pornography generally, at least in the U.S. So I just want to say DNS is a big deal, and it is that you could also look in our own space, the number of people who think that they have finally found a use for the blockchain and it's replacing DNS. Okay, great. Let me know how that works out, because it turns out that as soon as one person thought of it, 99 others also thought of it, and so they're all fighting for market share. The disadvantage of standards is you have so many to choose from. The advantage is that sometimes there is one that you can just say, I'm going to use that one, and DNS is that one. So I also want to talk about firewalls. In the early days, back in the sort of pre-commercial era, everyone who could reach you and everyone you could reach was a government contractor, because that's how you got on that research internet. And so they were all fairly trustworthy. Yeah, the students sometimes misbehaved, but generally not, because some sysadmin somewhere would disconnect the student and say, please forgive us, we didn't mean to let this guy on. But that, of course, was a bad start. It's like giving birth to a human child with no immune system and just putting them in a bubble and saying, well, it's fine, they don't need an immune system because there will be no germs. Yeah, well, eventually they outgrow the bubble and there are germs and there's no immune system. And that's kind of where we are. And you want to know why we have breach fatigue, why another 100 million names and addresses and social security numbers got released yesterday and probably again today while I wasn't paying attention, and no one cares. It's because this stuff is still laboratory grade at best. So hardening was needed, but there was no way to do it in the early day because we didn't know what was going to be needed. So eventually, when the internet got a little bigger, firewalls were invented as well as access control lists. It turns out you don't want everyone in the world to be able to reach whatever services you intend to reach sort of within your university or within your company. And yeah, that was a revelation. That was news. Traffic encryption, it's both not possible back with very expensive, very slow CPUs, but also not necessary in the early days. All of this is pretty common today, although I am regularly told that I should just secure my endpoints and that my firewall is out of vogue and that I shouldn't need one. And, okay, fine, you run your network the way you want and see how far that gets you. But, I can't secure my endpoints. I can't even identify my endpoints. So I'm going to keep my firewall. And so this whole thing that we do, where first we rapidly prototype something and get it working in the lab and then deploy it and then set our hair on fire when we realize the implications of what we've done, that's probably the hard knuckle at the center of internet culture. That's what got us here, and I don't think we will ever stop. And I don't love the implications for human history that this is the information age and this is how we're doing it. But I just want to say that as far as firewalls are concerned, a lot of us still have them. A lot of us still need them. Certainly all military and government and most commercial networks have them. I don't feel that, let's say, Amazon and Google are prepared to start buying conference room video controllers from each other and allowing them to contact their mothership with metadata. So I think there are probably still a lot of firewalls in the world, even among the people who are telling us we don't need them. So, if you're getting some pressure to give up your firewall, then yeah, you're not alone. So what is Protective DNS? So we want to be able to monitor it first. We want to know what DNS is doing because it can tell us, it can help us with detection, especially infections, of which, there's a new one every minute, and bots and botnets. Fairly often, I'd like to secure my endpoints. I don't know which ones to secure. Oh, I'm looking at the DNS. Now I know which ones to secure. It's the infected ones and the ones that are members of botnets. Thank you, DNS. I'm glad I was able to see that traffic, so I knew which endpoints to secure. You can also filter DNS, and that may prevent some infections because you could only get them from certain websites or whatever. And you could block some of the botnet command and control data paths. In other words, so the infection is there, the bot is there, but it can't find a place to learn who it's supposed to DDoS for hire, and so it's not nearly as painful. And, maybe we'd like it to be more painful so you fix it sooner, but actually that kind of tough love doesn't work, or at least it doesn't scale. So yeah, we like to monitor and filter our DNS. Now, obviously, the user and the application and the operating system have all got to agree to this. If they don't, they're going to start switching over to things like 8.8.8.8, and there's a whole bunch of other ones. I predict that all 240 or so possible n.n.n.n addresses will be DNS servers, probably by, let's pick a date, 2025. Because information is power, and DNS is where a lot of that power is. And so if you can get people to send you their DNS traffic, you are coming up in the world. But anyway, what this means is if you plan to monitor DNS and filter DNS, you have to be doing that in a way that your users are happy about. If you want to do things that they don't want to have done, then you're going to see 8.8.8.8 spray painted on the bombed out shell of a building during Arab Spring, and people are just going to bypass the servers that aren't letting them, reach Twitter or whatever it is. There's also something out there called DNS over HTTPS, which is an explicit, deliberate bypass of this type of monitoring and filtering. Although I think they had in mind nation-state monitoring and filtering. I didn't realize that actually we need this for sort of enterprise security and family filtering and everything else. And of course, VPNs, right? If people don't like what you're doing with your firewall, chances are you're going to let their VPN out. At least that's what works in hotel rooms. So I just want to say, I'm not talking about protective DNS as a way to do social control. I'm talking about cooperation where it's adding value in the eyes of the people that are getting it. But this is the post-Snowden era. In 2013, a U.S. defense contractor flew to Hong Kong and made a lot of disclosures, and that caused a lot of the world to suddenly realize that the world's an ugly place full of people that want to do bad things to each other, and especially governments who are in the dirty tricks business. The people who kind of already knew that said, well, I guess this was bad, but we didn't set our hair on fire. But a lot of people for whom this was news said, I don't want to live in a world that works that way. I want a different world. And so now we're seeing a lot of knee-jerk technology responses to those events. I mentioned DNS over HTTP, and that is just a way to make your DNS live inside of HTTPS or HTTP2 or HTTP3 or whatever you're using, and therefore become indistinguishable from a whole bunch of other traffic. But of course, it's been possible to distinguish web traffic because of the way TLS worked. You could see some of the metadata. And so now we have encrypted client hello. You may have heard of it as encrypted server name indication, or ESNI. That wasn't enough. Turns out they went back and said, let's not just encrypt that. Let's encrypt the whole hello. And that will make it impossible for a next-gen firewall to be able to say, okay, this outbound web request from some desktop of some employee of this mega corporation either does or does not conform to corporate security policy. Or they might say, hey, I wonder if this is something only a botnet would do, or what have you. That's going to be impossible soon, because all of the information that you need in order to intercept those sessions is being encrypted end to end. And so we're going to see the use of forced proxy soon, where every device in that big corporate network is going to have to agree to accept a key from probably some private key provider that is the company itself. I know a lot of companies have that. And they're going to say, look, you got to use the proxy. And here's the name of the proxy, and here's the key it's going to give you. And if you don't use the proxy, you're not going to be able to get outside the company, because we have to be able to have corporate security controls. And this is as natural as day following night. And it's not something you can legislate away. It's not something you can create standards away. And it's not something you can sort of change how everybody's laptop and smartphone works and suddenly, not need that, or start living in a world where big companies don't insist on it. We're also going to see something called QUIC. I forget what it stands for, but It will replace the TCP protocol with UDP, and it will have as perfect as possible an entropy level, which means you will not be able to tell what something is unless you are the person who sent it, or you have negotiated very carefully with the person who sent it because you are the person receiving it. And everybody in the middle is just going to see white noise, just total random, like indistinguishable from randomness. And that's going to be very hard for our industry, because we are used to being able to intercept, let's say, a connect request, because that would normally go to the kernel, Windows or Mac OS or a smartphone or whatever. The app would have to say, I want to have a connection to a place. Here's the address. Please let me know when you have it. And then you could intercept that. You could say, do I approve of this? Do I not? Do I want to log it? Do I want it in my audit trail? And, you know, if it's a torture chamber for captured malware, then you absolutely want to know when it's doing that. And now none of that's going to happen. It won't be a system call anymore. There will be no way for any endpoint security software or any endpoint threat researcher to know what the heck is going on in there. So the implications of this are probably more apparent to you listening to me than they have been to the people who have created these, because the folks that are creating them are just very good at creating protocols. They don't also have to secure anything, so they just don't know the implications. I have tried to explain it to some of them, and they tell me that I don't need a firewall anymore. So it's just, I don't think we're going to have a meeting of the minds there. But what this all means is that, you know, these endpoints and applications, our kernels, our libraries, our operating systems, our users, none of them are trustworthy. None of them should be allowed to communicate without having to declare their intentions and get some kind of oversight. But that is not what people believe in the post-Snowden era, the people that are creating all these protocols. And by the way, the folks at Apple and Google and Microsoft who bring us most of our endpoints are well represented in that community. So one expects that their companies are going to implement all of this. But that just means in the old days, you know, the internet came later. First, we had networks, and then we had the internet, which was a network of networks. And what that meant was the network was the atomic element of autonomy. It was the thing that you could control. It was the thing that you had to control. You would be responsible for whatever your network did. You couldn't say, I'm sorry, I'm DDoSing you. I don't know anything about what's going on with my endpoints. No. If you were DDoSing somebody, you had to stop. And that was the network of networks. Now we have the web, which was a network of eyeballs. And the networks are seen as irrelevant or sort of a meaningless abstraction, or in any case, they're inconvenient. So, you know, this is the post-Snowden era, and to secure networks the way that we used to do, all of this new stuff is going to have to get blocked, which is being made intentionally very difficult. Because if a company can do it, then a nation state can do it. And the nation states, I think, are the actual target of all this ambition. So that's sort of what brings us here to where protective DNS is something that the U.S. government is recommending everybody do, and that a lot of us have been doing it for 1 to 2 decades now. So, you know, if the app isn't bypassing it, or the library or the operating system or the user isn't bypassing it, then protective DNS is a very powerful security tool. And, you know, that's because nothing which can be abused won't be. And it turns out everything can be abused. Your user might be an intruder or just untrained and doing something that is unwise. Or they could be a malicious insider trying to, you know, steal all your source code for the, you know, whatever, go over to the competitor. There's a lot of terrible things that can go on there. So any kind of monitoring or control that isn't blocked can help security. And I do want to note that we read in the headlines about DNS failing, and all of a sudden some big e-commerce giant being off the net because some DNS failure happened somewhere, and that makes it sound like DNS is flaky and horrible, and it's not. DNS does trillions of things right every day, and it works too well. We have to break it. We have to be able to keep the people who want to hurt us from using this cooperative system to do it. So this is the picture I showed you all during Cyber Week in November, and this is the DNS topology. Questions come in at the bottom, usually from your web browser when you click on a link, or maybe from your shell app. If you say I want to SSH somewhere, then that's going to cause a DNS question. That'll go off to the stub resolver that's part of that particular operating system. So that smartphone, that laptop, that virtual server, that real server, that router, whatever it is, it's got a stub resolver. And it is configured to send your questions on your behalf to this thing in the middle. It's called a full resolver, or sometimes a recursive server. And that thing, that is the nightmare of complexity. That is where all DNS bugs are. Maybe only 99.999%. There may be a few bugs elsewhere, but this is where all of the really the stuff that has kept me up at night over the last couple of decades has been there. So if your stub resolver asks that thing, which is shared usually by everybody else that's on your Wi-Fi or on your network, if somebody else has already asked that, then it's cached. You'll get a copy of what they got, and you'll get a very fast answer. If not, it's got to go hunting it. And so to do that, it's got to go up to those authority servers on the top. And that's where the answers enter the system. Normally in a text file that looks like an old PDP-10 assembly listing, because that's what the inventor of DNS had as his example. It could be a database. If it's Akamai or some other content delivery network, it's not even data. It's a program that's answering these questions. But one way or another, the questions come in at the bottom, answers come in at the top. They meet in the middle, and you see this firewall that I've drawn here. This line that just says, I, the sysadmin, really want to force everybody inside my network to use that recursive server. I don't want them to use 8.8. If they do, I want it to fail. Because I want to be able to, answer their questions. If they come to me and say the internet's down, I want to know. I want to be able to help them. That's kind of the way it used to be. I'm going to be describing some things today that are over on the right, where we can now observe and analyze, and we can also have response policy. And there are some standard middleware protocols for that now that I'll give you the URLs for at the end. You see that thing on the end, that's applications doing their own DNS by speaking this DNS over HTTP protocol, bypassing your server, ignoring your firewall, and so on. So this is kind of the more modern view. Oh, wow, talk title, speaker name here. Sorry. Right, got to finish these slides before I show them to you. So, let me just say, we have to be able to do takedown. We, the productive side of the world economy, who builds the things, creates the assets that the unproductive side wants to steal instead of working for a living, we are going to have to cooperate, and we are going to have to self-defend. It is very clear that we cannot count on the secret world government of the United Nations to somehow go out to the far end where there is some ISP who doesn't care if we are hurt, who is selling services to someone's hurting us. We complain and they just ignore it, because why would they care? Takedown at the far end won't work. Takedown at the near end, which is to say every one of us doing it for ourselves, that won't scale. I used to spend a lot of time fighting spam and doing a lot of threat research in that area. And it takes a lot out of you, and you don't get much done. This really requires specialization. You're going to have specialization of knowledge and tools and you got to have attention. You got to have the time to focus on threat research. And not every endpoint that wants to protect themselves is going to be able to do that. So protective DNS can be seen as takedown in the middle. It's not at the far end. It's not at the near end. It's in the middle, because that's where it is actually possible to do something if a bunch of people want to cooperate to get that thing done, right? The people who don't cooperate won't be affected by it. They can still do whatever it is. And, that's the libertarian spirit of the internet. No one can stop you from doing what you want, but they may be able to stop you from doing it to them. So in the DoD announcement, what they said is, here's a bunch of cloud-based DNS providers that offer filtering or protective DNS, and you should, use one or use something else that's like this, but here are the ones that we know about. And when I saw that, I thought, that's good. I know a lot of people want to put their DNS out in the cloud, but I don't, and my customers don't, and a lot of my friends don't. That's why we have a totally different way to do what you're now calling protective DNS that does not rely on using the cloud. I thought it sure would have been nice if somebody from the DoD had contacted us and said, what's this RPZ thing? We're putting out an announcement. What do we say to people who don't want to use the cloud for their DNS? I could have told them. I could have pointed at a website that could have told them. Google could have told them. Anyway, protective DNS is something that a lot of users, a lot of families, a lot of companies want. If you don't want it, you're not going to get it. You're going to use a VPN. You're going to use whatever it takes that you don't get protective DNS. So please do not think I'm trying to ram this down anybody's throat. I just want to say, if you do want it, you ought to be able to get it. And if you're not going to trust the cloud with your DNS requests, either because you don't want those to be seen, or you don't want the external dependency, whatever that is, you have choices. And the choice I know about is the one that I helped invent. It's called RPZ. It's a DNS firewall. And I'm going to spend a lot of the rest of our time together explaining sort of what that is and how it applies to this situation. And then in the Q&A, which will follow this, I will participate in some demos and answer more technical questions. And we've also just released a video for those who are not going to attend the Q&A. So that's on the Farsight Security section of YouTube. I'll give you the URL on the last slide. So DNS firewalls were created at a time that a lot of us were still running our own name servers. And so it made sense to add the monitoring and filtering that we needed in DNS to the DNS servers that we were running. And since we had been through this once before by adding IP firewalls, we knew that an IP or a DNS firewall, which had to be configured with these 10 things, was never going to work. It would never scale. It had to be able to subscribe to a firewall policy feed. It had to be able to be federated. It had to have automation. And so when we built RPZ, we did it on a publish subscribe model. It is possible, and I do it, but it is possible, but it's very difficult to reconfigure the policy of a DNS firewall with these. You just don't walk up to a DNS server and say, I want you to start blocking something. It's much easier to get something from far away than it is to provide it directly. And that's necessary. And I want to say again, not all DNS server operators can afford to do their own threat research. And no matter how much they could afford to do, it wouldn't be enough. We have to have aggregation. We have to have specialization of labor. We have to have competition. We have to have companies out there that are saying, I want to be your DNS policy provider. I have something I'm publishing. You could subscribe. And then the next company will say, oh, no, take me, I'm better. Or maybe you take them both. That's how that works too. That is necessary. This is never going to take off if we don't make sure that nobody has to do their own threat research unless they're in the threat research business or it's their hobby, as I know it is for many of you. So the firewall protocols for DNS are DNS TAP for monitoring and DNS RPZ for control. And I won't be talking more about DNS TAP today, but I will give you a URL at the end. It's really cool. You should certainly look at what your DNS servers are doing and start either writing scripts or finding open source software that will parse that for you and tell you what it means. So Vernon Shriver and I worked at ISC when all this was going on. That's the Internet Systems Consortium, the home of Bind, also the home of FRoot and some other fine things. They have a very nice DHCP server as well. And since Bind is what we had, that's where we did the prototype. And, you know, it's the usual kind of thing. How should it work? Oh, I don't know. Let's try this. Oh, that worked. Okay, let's make that imperturbable for all eternity, even though we're going to wish we had put more thought into it. Well, sorry about that. That happened. But in the years since then, RPZ has stabilized. But not in any sense of the word abandonware. It's somewhat mature, and it's everywhere. There's no open source name server you could want to deploy that won't have RPZ support. And I really want to thank my colleagues at the companies who make these Unbound KEYNOTE, which comes from CZNIC in Prague. Power DNS comes from Amsterdam, or no, not Amsterdam, somewhere else in Netherlands. And, you know, everybody kind of looked at this first and said, oh, I don't know, you know, why I need that. But a few years later, everybody knew we had to have this. And it's cool to just watch this go. And it's not an IETF standard. This did not come from the same people that are bringing us quick and DNS over HTTP and so forth. So there is an RFC draft, and we do revise it periodically to clarify it and keep it up to date. And yes, I'm under some pressure to finish it and let it be published. And I really should do that, but I've been busy with my day job. And every DNS appliance that you might buy, especially from Blue Cat or Infoblox, they all support RPZ, and they will also try to sell you services. They have RPZs of their own because, hey, using DNS to deliver security is a pretty cool business model. So, yeah, this is out there. And if you didn't know about it, I'm glad to be telling you. If you did know about it, but you thought it didn't apply to you, I'm telling you it does. And here are the implications. Here's why it applies to you. So there are a bunch of available RPZ feeds. They're mostly not free. We'd like to see more free content, but it turns out giving stuff away is a thankless thing. I learned that from decades of giving Bind away. That's why one of the reasons that I decided my time at ISC would be over in 2013 is that I got tired of giving stuff away and having people complain about it. So that's probably why there isn't more free content. But hey, you're within the sound of my voice. If you've got ambition, go create a free feed. I will test it for you. I will put it on my social feed. I'll do everything I can to help you succeed. But I recommend you adopt a freemium business model so that people who want to use it commercially have a way to pay you. That'll be important to them and you and me because I want you to succeed. So the updates to an RPZ are streamed, and they stream continuously. So in my day job, we have one that changes every second. And indeed, we send a few packets to every one of our subscribers every second. And it works. It just keeps up. So it's like you pour the data in one side and gravity just takes it where it's going. And we use TSIG to control subscriptions and also to verify the identity of the far side. And so it's a relatively secure protocol. Certainly it's not encrypted because we don't think of DNS as secret. Maybe DNS policy should be a secret. We'll think about that later. And so any threat research team anywhere can publish their own results in this format. And when Vernon and I created this in 2010, we wanted to enable a services market of unconstrained size, an unlimited number of producers and consumers. And indeed, I expect that some of the cloud operators who are offering protective DNS are using RPZ in their own back office systems, because why wouldn't you? It works. But when we did this, we kind of thought that this would be more of a family filtering, corporate filtering, military, government kind of filtering market. Okay. So I mentioned that in my day job, we have an RPZ, a series of them actually, that we call newly observed. And these are just fresh domain names. When we first see one, and we have a big network, we see a lot. Nobody sees everything. Not even 8.8 sees everything, but we see a lot. So if we see it, it's probably new. And so every time we see it, we just put it into the RPZs. And customers get to decide which one they want. It could be the 10-minute one, the 1 hour one, the 24-hour ones, a bunch of different ones, because everybody defines new differently, right? So we know it's new when we first see it. We don't know how long it stays new. That's in the eye of the beholder or in the eye of the subscriber. But it turns out that breaking name resolution for fresh domains or domains that are still too fresh works, right? I've been blocking spam longer than probably anybody. And I block a lot, but when I added this to the name server that feeds my mail server, I blocked more spam, because you can't send email here unless every domain name in the SMTP envelope resolves. And it turns out a lot of them won't if you won't let fresh domains resolve. So that's an example of the kind of power you can get from something that has no machine learning, no artificial intelligence, nothing, just gasoline, oxygen, and flame, my team is busy with a lot of other things that we want to do in the RPZ space, but a lot of teams are very busy with that, and I love that. There's no patent on any of this. You don't need a license. You don't pay a royalty. You just open up. You can implement it in your name server without permission. You can publish without permission. You can subscribe without permission. It is sort of just a complete bazaar. And it's been great. And so sort of there's a reason I'm telling you this, because some of this I told you last year. There's a project out there called IOC to RPZ. And they are clearly aware that RPZ would be more meaningful if there was more content for it. And so they are working hard to try to get more things published in this format, and they're publishing some of their own. And they have a Raspberry Pi image that they make available for people who want to use this, who don't have their own name server. And so that's very cool because, and we've forked the Pi-hole project inside my day job to add RPZ there. And the reason is I think we're going to see a massive expansion of the set of people who want to run their own DNS. They don't want to use the cloud. They want to have control over what kind of filtering they're getting. They want to control who their security providers are and what the policies are. ThreatStop has had personal DNS, which is kind of like RPZ for Windows, for years now. And I'm expecting now that Department of Defense has said, yeah, you all need this protective DNS thing, that we're going to see this take off. Finally, it's going to be a lot of people who say, yes, protective DNS can be very useful. I want it. I don't plan to bypass it. Therefore, it's not irrelevant to me. So I'm going to install it, and I'm going to start controlling what DNS resolutions I have a hard fail for. Now, I should mention, I didn't want to kill you with PowerPoint. So not every one of these details is here, but it is here. Every detail you need to understand about what I've told you is at one or more of these websites. for RPZ, what I've mentioned is newly observed domain names, and that's an RPZ that we make at my day job. But that's only one example. You could also have a rule in a response policy zone that said, there's an ISP and it's in, I don't know, some country, and it's run by criminals, and Ripe or Aaron or some address allocator has been handing out address space to them because they don't know they're a criminal, and they keep coming back, every week or every month and getting more address space, and they just burn through it. They use it badly, and it gets added to Spam House and all the other real-time black hole lists, which is something else I co-invented. And then they get more address space. And so what you could do with RPZ is you could say, look, there's a /19 that was just given out to one of those ISPs. And I want it to be that any DNS answer, no matter what the question was, if the answer contains an address that's in that /19 address block, fail. And there are other things as well. I'm not going to go through the whole thing. You could find that at dnsrpz.info. But I'll give you another example of what you might do as failure, because the example that I've given is, it just doesn't work. Pretend it doesn't exist, and you can do that. That tends to make the web app give up and display an error page. But you don't have to. You could return a CNAME, which is a DNS alias. It's like a symbolic link in a file system. Therefore, you could get that website to say, well, I was looking for this name, but I got back from DNS an indication that that's not the true name. That's an alias, and that the true name, the canonical name, the CNAME, is this other thing. So I'm going to restart my query there. And it restarts that query, and that name will be the address of some server inside your security operations center. And so they'll get the address of that, and will fetch the web page from that and display it. And all of a sudden, the user who clicked on the thing that was dangerous will get a warning page. Hey, you clicked on something dangerous, and we prevented you from reaching it. This is what you clicked on. And this, by the way, is the next time that IT security training will be given in your area. I don't know what you would do with that sort of capability, but that's an example of how some universities have used it. And I know Lawrence Berkeley Labs uses it that way. So there's a lot you can do if you can constructively lie about DNS. And when I say constructively, I also mean cooperatively, right? If you're coming in late and you think that I'm offering this as a way to institute social control from an authoritarian government, I don't, because any such thing will be bypassed. So this really is a feature for those who want it. And what I want is that if I'm mindless and I'm clicking around on the web someday and I end up clicking on something that could hurt me according to some security provider whose policies I know and whose services I chose, I can get that information delivered to me in DNS form. And I can do that without having to use opendns or any of the other cloud-based DNS services that mostly all do filtering of one kind or another. You just don't necessarily know what it is. And if you don't like it, you probably can't make very many choices about changing it. And if it changes, then you probably don't have a good way of finding out it's changed. So there's a lot of reasons why you might want to have very close control over this. Or you might not. You might say, yeah, OpenDNS is fine, Cloudflare is fine, Quad9 is fine, whatever. All these cloud providers, they can offer you filtering, and you can study it to find out how it's going to behave. They're good companies. There's nothing nefarious about what any of them are doing. It's just not for me. It might not be for you. So that's it. That's what I came here to tell you for now. And in a few minutes, we're going to start up again in a different Zoom room with my colleague, Boris Terratine, who's jacking in from United Kingdom. So we have all three corners of the world represented on this call. And we're going to go through and show you sort of how some of this looks. so that if you want to grab a Raspberry Pi and play with it, or just, grab Unbound and play with it and stick it on some server you already have or some laptop you already have, that'll work too. So please do join us. Please do look at these websites. Please accept my thanks for your time. And I guess I hope to see you in person next time we're doing this.